met her smoking cigarettes in the men's room.
What is this tool and what's it used for?
Welcome to Making Stuff with Chris Dayhut in our segment titled This Maker's Tools. For today's tool, we're going to be discussing the edge finder. You've probably never heard of one. In this video, I aim to answer the following questions. What is the name of this tool? What is this tool used for? Who would use this tool? Why would you need to know where the edge of a part is? How accurate is this tool? What is the history of this tool? How does it work? How much do they cost? And finally, how do you use it? And then from there, we'll wrap it up. Most of these will be pretty quick, so it should be pretty fast-paced until I get into some more in-depth discussions. But the name of this tool is called an edge finder. It is also sometimes referred to as a wiggler. Yeah, exactly, a wiggler. There are two basic varieties of these. You'll have a cylinder, and then the tip of it will also be a cylinder. And then you will have the shank, which is cylindrical, and at the tip, in this case, it's conical. They both actually work the same way. The purpose of this tool is to allow you to detect the edge of a workpiece, such as so. And it's very, very accurate at doing that. Next up, who would use this tool? Odds are really good. There's not a lot of machinists in the world, so you might not, if you're not one, you won't know what this tool's really about. But machinists, these are people who use machinery to process parts into various shapes with substantial accuracy and precision. So they need a way to very accurately find the edge of something or find a reference point on something, which leads us into the next question. Why would you need to know where the edge of a part is? Edge finder allows us to find the edge of a part. Well, in order to machine features onto something in a specific location, you have to have a reference point on the piece. For example, if I want to machine a hole at that location, X number of distance down, Y number of distance over, I would use an edge finder to detect the edge of the part very accurately. That's the very key function of this. It's a simple tool, but incredibly accurate. How accurate is this tool? The accuracy is somewhat dependent upon operators. However, the tool's design eliminates a lot of potential errors. In the hands of an experienced machinist, edge detection can be within 0.0002 inches, or in the metric world, 0.00508 millimeters, which is a very small amount. So that you can get a perspective on that, if you take a sheet of paper and you slice that paper 15 times, the thickness of each slice of it at that point is 0.0002 inches. So we're talking about a very tiny amount. Now let's talk a little bit about the history of this. This isn't something new, and it does have a history, although in human history, it's a very brief period of time. Edge finders in various forms have been part of the machining process for at least 80 to 100 years. Evidence suggests their existence since the early 1900s, essentially the industrial age, as it evolved, where we started focusing on not just making something, but making something more accurate and more repeatable. A patent for a centering device was filed in 1909 and granted in 1912. Another patent for an edge finder was filed in 1945 and granted in 1950, and that's most likely really what we're seeing today and what I'm showing you now. Then another patent was also for an edge finder and a center finder. So I'm thinking at that point was when they introduced the conical point, and that was filed in 1956 and granted in 1958. Since its conception, the edge finder has continually evolved with the most recent innovation, which incorporates laser technology. So it's just been used and has evolved over time, and it keeps getting better. And that may be a matter of perspective there or opinion. Now, you might be asking, how does this thing work? It's rather simple, to be honest with you. We'll think of it as there are three simple points: the shank, the tip, and inside there's a spring. Now, the secret to it is how well they grind the two surfaces where these two pieces come together and the tension of the spring. As this thing is rotating, and this will make more sense when we get out at the machine and I show you how to use it, it'll start out off center, like so. Then, as you approach the workpiece, as we're coming into it, and I'll have this at an angle here so you can see what I'm talking about. As we come in, and this is rotating, eventually this will line up perfectly and it'll run perfectly true. But by eye, you really can't differentiate it if it's running perfectly true or it could have maybe 0.0005 tenths of a thousandths wobble to it. But the magic of it is, as soon as it comes into proper full contact, it's going to kick out to the side while it's rotating, and that is your indicator that you are in perfect contact with the edge of your workpiece. As you can imagine, the quality of the tool is going to play very critically into the precision, accuracy, and reliability of this tool. I personally have a collection, as you can see, and these two here, I'll talk about in a minute, are from brand name manufacturers, and I've actually had these for about a half a century, maybe a little bit less, but about a half a century. These I've picked up along the way, and they're no brand name, very economical, and frankly the reason why I ended up buying these is because I misplaced these for a long time, so I needed some. But they don't work nearly as good. I'll flat out say that. So I almost never use these anymore. In fact, I dug them out of the toolbox, had to polish them up because they're all rusty. But nonetheless, what you've got is a very precise tool that is dependent on precise manufacturing processes. So this is one of those things, invest in a quality one and it will serve you well. With that statement out of the way, the next thing that's going to come into mind, what do these things cost? As I mentioned, there will be a big price range for units like this. And if there's a brand name associated with it from a reputable manufacturer, the price will be high. But you will be assured it's most likely going to work very good. With the very low cost ones that are a couple of dollars or $5 off of Amazon, you'll find that you're going to be very disappointed in their performance. So I'm focusing the pricing on a tool that you will buy that actually works as advertised. Now I've got two of them here that I've had for a very long time and have served me well. This one here is made by a company called Brown & Sharp. They're Brown & Sharp's U.S. manufacturer of machine tools and inspection tools. And that company has been sold off to other companies over time. But this Brown & Sharp version you can still buy. It is made by another company, but it's all still the Brown & Sharp stuff. It's $30 list price and $25.02 on Amazon, and these prices are US. This style, which is my preferred style, is another type, and it is from a different manufacturer. This one happens to be from a manufacturer called Mitutoyo, a Japanese manufacturer of high-quality precision measuring instruments. This one has a list price of $20.85, and you can pick them up on Amazon for $16.55. Again, U.S. prices. I'll put links to who the new owner is, Hexagon, for Brown & Sharpe. I'll put links to that and to Mitutoyo down below in the description so that you can dig into it a little bit deeper if you so desire. Next up is, how do you use these things? For that, the best way is to show you how it's done out at the milling machine. To demonstrate how to work with the edge finder, we'll be using my milling machine, which is outfitted with a digital readout over on the other side. That allows me to do that shift over from where I'm touching the edge of the part to being on the edge of the part very easily and very accurately. I could also use the dials on my hand wheels, but the older you get, the harder it is to read them. For the purpose of this demonstration, I'm going to pick up this edge of the workpiece. So I'm going to make sure as I come down that I'm clear. I'll turn on the spindle, and you can see that the edge finder is wobbling dramatically. That's actually what we want to see right now. What I'm going to do, I will feed in till I make contact, and you'll notice that the wobble is getting less and less. Now I'm going to start going really, really slow on the dial until you'll see it shift to the side, the very tip, this lower portion. Once I'm perfectly in contact, it will shift one way or the other. Now you can see how the tip of the edge finder shifted over. That's perfect. We came into perfect touch. You need to stop as soon as it does that. You don't want to keep feeding in to go too far. Now at this point, I am half the diameter of this tip away from center line. So I need to come over the radius of this diameter, which happens to be 0.2 inches. The axis I was moving was the y-axis. I'm on the far side of the piece, which would be y of plus 0.1. So I could preset it to y 0.1, enter. And then I could jog the table over to 0, and that would bring the edge finder into perfect alignment with that back edge of the workpiece. To wrap up this video, I'd like to say that while the edge finder's application limits itself to a very small group of people, it is nonetheless a very important tool. Without it, over the years, it would have been much more difficult to make precision components. Precision components make all machinery run and run properly, and if they're done right, even last a very long time. Edge finders are still in use today. Obviously, you can still buy them, but other technologies are becoming more popular, such as electronic probes or even laser edge finders and those sorts of tools. Either way, I still think this tool is going to be around for a lot longer. Well, that'll wrap up this video covering the Machinist tool called the edge finder. If you found this video interesting, I would appreciate it if you could subscribe, share it with other people who could be interested in this sort of information, or even drop a comment below. I'd love to hear what you think about these tools that I'm presenting. It greatly helps the channel to grow, and without that growth, I can't continue the channel. Thanks for watching, and I look forward to seeing you in the next video.